two major theorems in polynomial are the remainder theorem and the factor theorem. In this video, we shall consider the remainder theorem. I want to state remainder theorem and then see how we apply the question, and then subsequently we'll consider factor theorem. The remainder theorem statement. It states that if you give it a polynomial, say p of x, that is a function that depends on x, to be divided by x plus or minus alpha. You can see I've used x plus or minus alpha here. That's to tell you that the sign between this x and this constant alpha can either be plus or it can be what? Minus. Alright, according to remainder theorem, the remainder r is simply p of minus plus alpha. That's going to be the remainder. Now, what do we mean by that? Let's watch. You take note that this is x plus or minus alpha. If you make x plus or minus alpha equal to 0 here, you'll agree with me that this is going to give you x equal to minus or plus alpha. Watch. If you have this, then you move this plus or minus alpha to cross the equality sign. The value of x will now change to minus or plus alpha. You know, if it is plus and alpha crosses, it will become minus. If it is x minus alpha and alpha crosses, the value of x will give you what? Plus alpha. Is that okay? Alright, so that's the essence of this. That is sign change once you want to get the value of x here. So just think of this: if you're given a polynomial, and then you're asked to divide that polynomial by a linear factor. Linear factor is one in which the highest power of the unknown is 1. If you make that linear divisor equal to 0 and then solve for x, the value of x now, go to the polynomial and fix in the value of x in that polynomial. Then simplify and then you get your result. We have the proof here on the board. Now, generally, this is the expression for polynomial division. We saw it when we were treating division of polynomials. We saw it. Now, if you clear this fraction here, how do you clear the fraction? You multiply all the numerator by the denominator, x plus minus alpha. If you do that here, x plus minus alpha using to multiply p of x, we cancel or divide itself. You'll be left with p of x equal to q of x, multiply this q of x by x plus or minus alpha, multiply this r by x plus or minus alpha, it will cancel this denominator, so you have this expression. Now, if the x plus or minus alpha is set to 0, if you make it equal to 0, just like I told you here, you can get the value of x to be equal to minus or plus alpha. Sign will change, when a constant crosses equality sign. And that gives us the value of x to be minus or plus alpha. That value of x, which is minus plus alpha, substitute it for x in the given polynomial. Substitute it for x in the given polynomial. This is the polynomial. Look at it. So if you substitute it, the value of that x, which is minus or plus alpha, you're going to get this. This will give us p of x to change to p of minus or plus alpha equal to q of minus or plus alpha. Then bracket, this x is minus or plus alpha. Look at it, minus plus alpha. Then plus or minus alpha. This term and this term are the same thing, just difference in sign. So for example, if this is minus 2, this will be plus 2. If this is plus 2, this will be minus 2. And they work out to give you 0. So plus 2 minus 2 is 0, or minus 2 plus 2 is 0. And that is why in the next line, I have this term 0 there. If you multiply this 0 by this quotient, you get 0, and then p of minus plus alpha, where minus plus alpha is the value of the x you obtain by making the divisor equal to 0. Is that not so? You see that automatically substituting the value of x into the polynomial will give you what? The remainder r. So that's just the remainder theorem. We have a question that I want to quickly look at, okay? So we have the solution. This is the polynomial. We have to divide it by the divisor x minus 2. So after here, now is at minus 2. So what do? We will set x minus 2 equal to 0 and then get the value of x. If this minus 2 crosses, it will become plus 2. You see that sign change, is that not so? Alright, so go to the polynomial and then substitute that 2. So our p of x, this is the polynomial, will now become p of 2 because the value of x is 2. And that will give us, substitute 2 for x in this expression of this polynomial. So that is 3 bracket 2 raised to the power 3 plus 8 bracket 2 raised to the power 2 minus 2, then minus 12. So p of 2 will now give us 2 raised to the power 3 is 8. 8 times 3 is 24. This will give us 4 times this 32. 32 plus your 24. If you have 32 plus 24, you get 56. Now that 56 minus 2 will give us 54. 54 minus 12 will give us 42. And so this is 42. Therefore, our remainder is equal to 42. That's simple. This was, the first question we solved when we treated polynomial division using long division method and then the Omakers short division method. Suppose that question asks us to get the remainder directly. We don't have business with the quotient. No need of doing all this long division or Omakers short division. If it is only the remainder, simply use the remainder theorem and get your result. Question number 2 under our remainder theorem. It's past question 2008-2009. Question number 22. We have to find the remainder when 3x squared plus 2x plus 1 is divided by 2x minus 1. Alright, now in summary, we have our polynomial. This is what we are dividing by 2x minus 1. So we can use either the long division method or the Omakers short division method to get our result here. But that would have been necessary if we were asked to find the quotient of this division. Is that okay? Since it's only the remainder that we're asked to find, it's ideal to use the remainder theorem. Especially so as the divisor is a linear divisor. Take note that the highest power of the unknown here is what? 1. As it is a linear divisor, are you getting me right? It is ideal to use remainder theorem. If it were to be a quadratic divisor per se, I would prefer that you use either the long division or the Omak's short division method. But since it is a linear divisor and you are asked to get only the remainder, please go straight ahead and use remainder theorem. So I would say that let 2x minus 1 equal to 0, and from here x will be equal to 1 over 2. Is that not so? Because you move 1 to this side, it becomes plus 1. So you have 2x equal to 1 and then divide through by 2 to get x equal to 1 over 2. So what do? Go to P of x, and then wherever you see x, put 1 over 2. This is our polynomial. So we're going to substitute 1 over 2 for x. So we get 3 into 1 over 2. I'm going to square it plus 2 into 1 over 2, then plus 1. All that is left is simply to simplify what is there on the board. Mathematically, if you have 1 over 2 all squared, in this it tells you that the square will affect the numerator and the denominator. So you deal with 1 square, you get 1. It's going to be 1. All over 2 squared will give us 4. Then plus here, this 2, we cancel this 2 because you need to open up the bracket straight. Since there is only power 1 here, are you getting me right? So this 2 will divide this 2. You'll be left with 1 there, and that 1 will be added to this 1 here. So you take note that P of 1 over 2 is equal to 3 over 4 plus 2. If you work out the LCM of that, you get P of 1 over 2, which of course is the remainder, you know that. LCM of that, adding a fraction to a whole number is an easy one. You have the denominator times the whole number, which will give you 8 here, plus this 3, that is 11 over 4. Or you can write this as 2 whole number, that is a mixed fraction, 3 over 4. Either of them is accepted. Therefore, you can see, remember that according to remainder theorem, P of minus plus alpha, that is, putting the value of x into the polynomial, should produce the remainder. Therefore, the remainder here is 11 over 4, or, like I said, 2 whole number, 3 over 4. In the next video, we're going to consider remainder theorem when the divisor is a quadratic divisor. In this video, we want to consider what the remainder of dividing a polynomial by another one would be in a case where the divisor is a factorizable quadratic divisor. Factorizable quadratic divisor could be of this term, that which contains the 3 terms of a quadratic expression. Is that okay? It could also be of this term where you have the x squared term and the constant in such a way that the constant is a perfect square. For example, x squared minus 1, x squared minus 4, x squared minus 9, x squared minus 16. They are all factorizable quadratic expressions, but they contain only 2 terms. We use difference of 2 squares there. Is that okay? Difference of 2 squares. All right. Now we can also factorize this. You can be given a quadratic expression of this form that can factorize. So what happens in the case where a polynomial is to be divided by any of this form of factorizable quadratic divisor? What will be the remainder? Now, I'd like to say that the idea we used when dividing by a linear divisor is still the same idea here. According to remainder theorem, the whole idea is this. If you're dividing a polynomial by another one, for example, what you do, get the value of x from the denominator, from the divisor. Now that value of x, go to the polynomial and substitute it and replace x with that value of x you got from the divisor. That's just the idea. Simplify and you get your remainder. So we can apply the same reasoning, the same idea to a case where the divisor is a quadratic expression. Now, what will be the remainder in that case? It's not going to be as simple as what we saw in the case of linear denominator. Are you getting it? In this case, where you are dividing the polynomial by a given quadratic denominator, the remainder will be this. Look at it. Ax plus b, where a and b are real numbers to be obtained. So you are the one to determine the value of a and b. Is that okay? Now, as a quick proof, we just have this on the board here, all right? You can go through it. I'll just highlight or summarize what is here. You notice that we've got equation 1 and equation 2, which means that to get the remainder finally, you need to solve equation 1 and equation 2. But look at the whole idea here, If the quadratic denominator expression can be factorized, as we said, then we expect that, okay, let this be the factors. Is that okay? That the factors are x plus minus alpha and x plus minus beta. Now, did you take note that we've broken down this quadratic divisor, quadratic expression to 2 linear expressions? Look at this. The power of x is 1 here, the power of x is 1. So by factorizing the quadratic expression, we get 2 linear divisors. So use each of the 2 linear divisors, get the value of x. Are you getting me right? From each of them, go to the polynomial and substitute. Now take note, the general expression for polynomial division, just like we met under the short division method or the long division method. This is the expression, this is the polynomial to be divided by another polynomial. But in this case, the quadratic expression is factorizable. We say, okay, let us assume that we factorize it, and this is what we got. So it will be equal to the quotient plus a remainder. In this case, say the remainder of the ax plus b to be divided by the divisor still, okay? Now what do? Clearing the fraction here, this is what you're going to get. The LCM is x plus minus alpha, x plus minus beta, so you can use it to multiply all the numerators while cancelling wherever it's necessary. If you clear the fraction, this is how the polynomial is going to look like. Polynomial will be this. And then from either of the divisors, the linear divisors you obtain from this factorization, you can get the value of x there. In this case, look at it, set this denominator or this divisor or factor equal to 0, get the value of x. We've seen this before where the sign changes minus plus alpha. Obtain from what? Plus minus alpha is answer. So if you do that, obtain the value of x, go back to this polynomial and substitute. If you do the substitution, this is what you're going to get. So you can go through the expression. Now take note of something, that this term will become 0. This term will give you what? 0. It will give you 0. Let me trace it to this. Is that okay? Plus minus alpha and minus plus alpha will give you what? 0. This is meant to be minus plus alpha, the value of x. Yes, minus plus alpha. So it's going to give us what? 0. Is that okay? And if this term gives us 0, 0 times this will give us 0, 0 times this quotient will give us 0. So this whole term is equal to 0. You'll be left with this term. You can see that here. So the polynomial with the value of x substituted, which is minus plus alpha, obtained from this factor, is that answer, would give us this expression. This is one equation with two unknown, a and b. So you call it equation 1. Go back, set x plus minus beta equal to 0 again and obtain the value of x. In this case, it will be minus plus beta. Repeat the same process. So it's like this is really a simple thing. Are you getting it right? Go back and then fix in the value of x you obtain, which is minus plus beta, considering this factor. If you do so, you're going to get this. And then take note, once again, that this will become 0. To become 0. If it becomes 0, what is going to happen? 0 multiplying this bracket and this quotient turns these whole terms to 0. And that's what we have here. So that p of minus plus beta, that is the second value of x you obtain from the second factor, will now be equal to this term. Call it equation 2, then solve equation 1 and 2 simultaneously. And then you get your remainder ax plus b. Guys, in the next video, we're going to pick a question to apply this principle. In this video, we have this question I want to solve applying what? Remainder theorem. In the case where the divisor is a quadratic expression, a factorizable quadratic expression, to be specific, factorizable quadratic expression. If the quadratic expression is not factorizable, then do your normal long division or use the Omakase short division method. Is that okay? Now, before we move on into solving this question, I'd like to state, you see, we're asked to find the remainder when x cubed minus x squared minus 17x minus 15 is divided by x squared minus 3x plus 2. You see, for questions of this kind, it's even preferable to use either the long division method or the Omakase short division method to obtain your remainder quickly, rather than going through the concept of the remainder theorem for questions of this kind. Alright? However, because we're treating remainder theorem, I'm going to use the idea of what we proved to solve this problem. Does that make sense? Okay, then I also like to state that it is true that I say questions of this kind, it's even preferable go straight use the long division method or Omakase short division method. However, if in the question this polynomial contains an unknown, are you getting me right? Something you don't know, maybe unknown coefficient. Let's assume this 17 is not given, it's a constant which we need to find out. Then it becomes much more ideal to use the remainder theorem directly to solve. Anyway, let's keep all those aside and solve based on what we are trying to learn here, the remainder theorem. Now what do we do? This is the polynomial given to us, this is the divisor, and so I'm going to check if the divisor can factorize. And of course, the coefficient of x squared is 1. To factorize a quadratic expression, first you use the coefficient of the term bearing square to multiply the constant. So coefficient of x squared is 1, 1 times 2 is 2. Are you following? Then find two numbers of this plus 2, which if you add, you get minus 3. Those two numbers which are factors of this plus 2, if you multiply them, you must get this plus 2. And if you add them, you must get this minus 3. So that's the principle of factorization. Now the numbers there are minus 1 and minus 2. Minus 1 times minus 2 will give us plus 2. And minus 1 plus minus 2 will give us minus 3. Please, I urge you all to practice your multiplication table very well. The secret of all this factorization is based on how well you know your multiplication table. Because the factors which must be added to get the middle term are actually a function of your knowledge of multiplication. Okay, now let's go. So if you say that the numbers that you can multiply to get plus 2 and add to get minus 3 are minus 1 and minus 2, then in factorizing these, the factors of this will now be x minus 1 and then x minus what? 2. This becomes like your x plus minus alpha, your x plus minus beta. Now you know that in dividing a polynomial by a factorizable quadratic expression, taking our mind back to what I derived in the previous video, you now know that each of the polynomials, alright, produce a remainder if you substitute the value of what? X. We had equation 1 and equation 2 in our previous video before now. And then you notice that p of the value of x, you solve it, it will be equal to a term containing the remainder. So, on the basis of that, I am going to say, recall, p of x, that's the polynomial, is equal to the remainder ax plus b. That was what we actually got in equation 1 and equation 2 when we were trying to derive this remainder theorem with quadratic divisor. Our polynomial is this, our remainder, okay, ax plus b, this is the remainder. So all we need to do is to get the value of x and substitute. However, this means that x cubed minus x squared minus 17x minus 15 should be equal to ax plus b when you fix in any of the values of this x. Alright, now let me write, let x minus 1 equal to 0, you know it implies that x will be equal to 1 from here. So I will come to this equation and then fix in 1. Okay, now this will produce 1. This bracket 1 square is 1, 1 minus 1 is 0. This is minus 17 if you multiply it. This is minus 15, minus 17 minus 15 will give us minus 32 equal to a plus b. This becomes our equation what? 1. A plus b, 1 times a is a. Okay, now we do same again. Also, let x minus 2 be equal to 0 considering this. From there, you get the value of x to be equal to 2. Repeat the same procedure. Substitute for x in this expression. If you substitute for x in this expression, you're going to get this. If you work out this will give us 8. 8 minus, this is 4. You get 4 here. 8 minus 4 will give you 4. Then this time if you multiply it, you get minus 34. Minus 34. Now you have plus 4 here. 4 minus 34 will give us 30. That is minus 30. 4 from this term minus 34 will give us minus 30. Minus 30 minus 15 will give us minus 45. So minus 45 is equivalent to 2a plus b. This becomes equation 2. Once you generate the equation, your problem is solved. It's all about solving this using what? Any of the method of simultaneous equation. I prefer to use the elimination here because b in equation 1 and b in equation 2, they have the same value. 1b, 1b. So I can subtract any of the equation from the other one to eliminate b. So I'd like to do equation 2 minus equation 1 in solving simultaneously using the elimination method. So that would be minus 45 minus, you know you're doing subtraction, minus 45 minus 32. You know minus will give us plus. So you have minus 45 plus 32. And minus 45 plus 32 is same as 45 minus 32. Any answer you get, you put minus. So this is going to give us 3, 1. That should be minus 13. So however, it implies that minus 13 will now be equal to 2a minus a will give us 1a, which is simply a. b minus b is 0. You've eliminated it. Therefore, you take note now that a is equal to what? Minus 13. Now that I've gotten a, I can get the value of b by substituting this value of a either in equation 1 or in equation 2. I would like to use equation 1 because equation 1 contains, smaller numbers compared to equation 2. But you can still use equation 2 to get your result. So I'll now say put a equal to minus 13 in equation 1. I would like to write the statement out. If you do that, you're going to get minus 32 equal to the value of a is minus 13. Minus 13 then plus b. Make b subject of the formula. Minus 13 will cross. If minus 13 crosses to this place, it becomes plus 13. So b is 13 minus 32. 13 minus 32 is the same as doing 32 minus 13. Any result you get, you put minus there. And if you work on this, you're going to get that b is equal to minus 19. So we've gotten our remainder ax plus b. Why? Because we know a already and we know what? B. Therefore, the remainder, which is equal to, from here we've got b to the minus 13. Remainder which is equal to ax plus b will give us that remainder is equal to a is minus 13x and b is minus 19. That minus will change this plus to minus. So this will become your remainder, or you can write it as minus, open brackets, 13x plus 19. That is by factorizing minus that is common. Either of them is still the same result. Now if you take your mind back, we've actually solved this question before under polynomial division, and this was what we got. The next video we're going to consider another question where we would use difference of 2 squared as our divisor. We now have this next question on the board, and we will be pretty fast, okay? We have to find a comma b such that x cubed plus 2x squared plus x minus 1 divided by x squared minus 1 is equal to q of x plus ax plus b all over x squared minus 1. Already, this expression is not new to us again based on what we did previously, okay? So you're dividing this polynomial by another polynomial, you get a quotient, you get a remainder, and then the remainder to be divided by what? The divisor still. Now, the focus of this question is to obtain the value of a and what? B. And if you look at these, a and b, they form the remainder here. And then the divisor is a quadratic what? Divisor. So what does that tell us? Now simply we move on and say that, okay, p of x from the question given to us is equal to, and then our divisor, you can factorize this. X squared minus 1 is difference of 2 squares, because that is x squared minus 1 squared. And that's going to give us x minus 1, bracket x plus 1. Take note that 1 is a perfect square. This question could have been given, and then the divisor is x squared minus 4. In that case, you get x minus 2, bracket x plus 2 as your factors. Is that okay? Now, recall that in a case of quadratic divisor like this, that we have the polynomial p of x to be equal to ax plus what? B. That's the polynomial is equal to ax plus b, the remainder. And now we know the polynomial is given as this already. Example is given as this. That implies that x cubed plus 2x squared plus x minus 1 is equal to ax plus b at the value of this x. So we now want to get the value of x from each of these. So for x minus 1 equal to 0, you obtain that x equal to what? 1. That implies that you come to this and fix in that 1 place. I'm going to do it once, okay? I wouldn't show the substitution. If you fix in 1 here, 1 cube will give you 1. Is that not so? Put in 1 here, 1 squared will give you 1. 1 times 2, 2. 2 plus the 1 here, this time will give you 3. Fixing 1 here, you get 1 minus 1, 0. So this part is 3 equal to, then fixing 1 here, you get 1 times a, which is a plus b. Call this equation 1. Also, you're going to do for x plus 1 equal to 0, you get the value of x to be equal to minus 1. That's from this factor. Is that okay? Once again, go back here and then substitute. Alright, it implies that if you fix in minus 1 here and you raise it to power 3, it will give you minus 1. Fixing minus 1 here, you square, it will give you plus 1. That plus 1 times 2 will give you 2. Take note, a negative number raised to even power would give you positive of your answer. But if it is raised to odd power, as in this case, it will give you negative of the answer still. So remember here we had minus 1. This part gave us plus 2. Minus 1 plus 2 will give us plus 1. Will give us 1. Are you following? Now, fix in your minus 1 here. That minus 1 plus the 1 we got from here is 0. You'll be left with what? Minus 1 if you substitute. So this is going to give us minus 1 equal to, come over here, fix in your minus 1 for x. Minus 1 times a will give us minus a, then plus what? B. This will give us equation 2. All you need to do is to solve equation 2 and 1 simultaneously. Of course, I want to do one of the equation minus the other one. This time around, I wish to do equation 1 minus equation 2. It doesn't matter, you can do equation 2 minus equation 1, you still get the same result. Okay, equation 1 minus 2, now watch. It's going to give us 3 minus 1. And that minus 1 will become positive 1. 3 plus 1 will give us 4. Equal to, then a minus a. That minus a will give us plus a. A plus a will give us 2a. And then b minus b will give us 0. B will go off. You know, the reason why I'm using minus is I want to, I notice that a here, they are the same, they are equal. 1, that is bb rather, bb are equal, 1b, equation 1 and 2. So if you do your subtraction, since they have the same signs you subtract to eliminate. If I wanted to eliminate a here, I will add equation 1 and equation 2. I will add them up. Are you following me? And if I add them up, this will give me a plus minus a, which is a minus a equal to 0. The same signs you subtract to eliminate. Different signs you add to eliminate. Okay, so from here we'll get our a to be equal to 2 if you divide through by 2. Having obtained a, I can now get my b. Put a equal to 2 in equation. You can use any of the equation you like. You can use equation 1, you can use equation 2. If it is in examination hall, using equation 1 will be fair enough than using equation 2 because of this minus. However, I'd like to use equation 2 here. Is that okay? So let me say substitute a equal to 2 in equation 2. So that's going to give us minus 1 equal to minus, in place of a you put 2, then plus b. Solving for b, b will be equal to minus 1 plus 2. And then the value of b will give us 1. So you notice that a comma b, therefore a comma b, as the question asks us to find, is 2 comma what? 1. 2 comma 1. That's the answer. If we were asked to find the remainder directly, ax plus b, all I need to do is a is 2. You fix in 2 here, you have 2x plus b is 1. You fix in 1 for b. In fact, let me write it. Note, remainder r equal to ax plus b will give us that r is equal to a is 2. That is 2x plus b is 1. So that's the remainder. We now have this next question on the board. P of x is equal to x squared minus 3x plus 2, and f of x is equal to kx raised to the power 4 plus nx raised to the power 3 plus 3x raised to the power 2 minus 2x plus 3. Now, f of x divided by p of x. So you take note that f of x is our numerator now. So that will be on top to be divided by p of x. Which means the main polynomial under consideration here, which we usually make equal to ax plus b, will be this f of x because that's the numerator, no longer p of x. Here, p of x is the denominator. Are you getting right? So, f of x divided by p of x leaves a remainder ax plus b, which according to the question is equal to x plus k. The remainder is equal to x plus k. So find k comma n. Now, the principle is the same as what we've done so far in question 1 and 2. So we're going to apply the same knowledge. Let's be fast to get this result. Is that okay? I will start by saying that, okay, the polynomial, which is the numerator, is equal to ax plus b. Does that make sense? And here the numerator is f of x. So I'm going to say, recall, f of x is equal to ax plus b. That's good. And according to the question, ax plus b is equal to x plus k. Which means if I'm working out this, I'm going to equate this term to this. Does that make sense? That's the point. Alright, so it simply implies that our f of x is given as kx raised to the power 4 plus nx raised to the power 3 plus 3x squared minus 2x plus 3 and is equivalent to x plus k. Now we move on to the divisor. Divisor is given to us as p of x which is x squared minus 3x plus 2. This is equivalent to x minus 1 x minus 2 if you factorize this. Is that okay? So take note of this. This is just like x plus or minus alpha, x plus or minus beta. Okay, so I would say when x minus 1 equals 0, it implies that x will give us 1. You know what we do with that value of x? Go to this expression and substitute its answer. So it implies that if you work out this, 1 raised to power 4 is 1 times k, you have your k here. Similarly, here this is 1 times 9, if you work it out, 1 times n, you get your n. This bracket squared is 1 times 3, you get 3. And then this is minus 2 plus 3, equal to 1 plus k. Mathematically, if you collect your k together, you have k minus k, so it will go off. Now, we'll be left with n. 3 minus 2 is 1. 1 plus 3 will give us 4, equal to 1. So do you see that from here, you can get the value of n? It implies that the value of n is equal to minus 3. We've gotten that. So substituting x equal to 1 straight, using this factor, produce our n for us directly. So there is no need of calling this one equation 1 because you've gotten the value of your n already. We'll go to the second one. When x minus 2 is equal to 0, that implies that the value of x will give us 2. Repeat the same thing. Go to this equation and then substitute x equal to 2. It implies that. Does that make sense? Simplifying this, 2 raised to power 4 is 16 times k, 16k. This one will give us 8n. This will give us plus 12. This is minus 4. And then plus 3 equal to 2 plus k. We can move on to solving this and see what we're going to get. This will be 16k plus 8n, and n is equal to minus 3 already. Then plus, can we work out this and see? 12 minus 3, minus 4 rather will give us 8. 8 plus 3 is 11. So 11 equal to 2 plus k. If you collect your like terms, 16k minus this k will give us 15k. Then this 8 times 3 is 24. And because this is minus, you're going to get minus 24. Minus 24 plus 11 will give us minus 13. Alright, minus 24 plus 11 will give us minus 13. So we're going to put minus 13 there. Minus 24 plus 11 would give us minus 13. And then that will be equal to 2 plus k. Alright, we've moved our k already. So it will be equal to 2. So that 15k will be equal to 2 plus 13. 15k will give us 15. Therefore, k is equal to 1. If you do 15 divided by 15. Alright? So we are done with this. We are asked to find k comma n. It implies that k comma n is equal to 1 comma, our n is minus 3. This is our answer. Alright, we've gotten what they asked us to find there, but please, let's quickly look at something. Note, from what we did here, you notice that your x plus k, which is equal to ax plus b, will give us that x plus, the value of k we got is 1. So you fix in 1 equal to ax plus b, ax plus b. So the remainder actually here is equal to x plus 1, because we've gotten our k already. Are you following? And suppose the examiner asks you to obtain the value of a comma b. Also, if you compare, you notice that a is equal to the coefficient of x, look at it, which is 1, and then b is equal to the constant term, which is k, 1. So in case you ask a question like this, you want to take that, and you can also obtain all those values from there. Next, we're going to look at factor theorem of polynomial.